Okay, so today we are going to look at the technology pieces of this stuff. So a lot of these things will be graph for you, or we're going to learn how to use our graphing calculators a little bit better today. To start out though, let's say you have something graphed and you need to write an equation for it. So the equation that you're going to want to put it into is in vertex form, where a is my slope, we got x, and it's always the opposite of your h in here, or where this is your x vertex, and then plus k, which is your y vertex. So we're just going to find those points in here and try to write that equation. So when I look here, my vertex is up there, and that for us would be at the point 2, 1. So when I write it in here, I'm going to have y equals x minus 1, because I always put the opposite in there, plus 2, because it's up at 2. Now we got to look for its slope. And you can find its slope just like you find the slope of a line by taking your starting point and going down and over. And I didn't draw that very well, but if you go down 1 and over 1, well, actually it looks like we'd have to go a little bit more. We'd have to go down 2, or down 1 and over 2. So our slope in this case would be down 1 and over 2. And that would be my answer for this. So when you're writing these things, you're going to want to write them in vertex form. You always plug this as your x vertex. You always plug this as your y vertex. And then you'll find your slope by starting from this middle point and checking how this goes. So as you can see, we go down a full 1 from 2 to 1, and then we go over 2 on our axis. Okay? I'll have you try those problems. We're going to move on to the next type of problems. For this problem right here, they want us to find the x-intercepts of this. And so if we know a parabola makes this kind of U shape. And so it should, if you think about it, it should cross the x-axis either twice when it goes this way, or when it goes twice the other way, or the last case would be that it doesn't cross. So you either get it to cross twice. Technically you could get it to cross once if it starts right on that line. If I could draw that a little bit better. But if it starts right on that line, it could cross once, but we want to find where this thing crosses. For today, there's a lot of ways to solve this, and there's a lot of ways to solve this by hand, but I think it's easiest to solve this by the graphing calculator. So what we're going to do is we're going to pull up our graphing calculator. We're going to click on that Y button right there, and then we're going to just type in that equation. This is how you hit an x squared minus 16x minus 12. And then you just hit this graph button. And you're going to see my parabola. It's not the best. If you want to see the full view of it, if you click on this windowed button, you can increase this window size. Whoops. So you can increase this window size and include more points. On our y-axis, we might want to go from negative 20 to positive 20 to just get a better view. It still goes a little bit off, but you can see that down there it's going to do that. If you want to see the actual points, you can hit second table, and you can see that it gives me an XY table right here. What we want to do though with our graph is we want to find the two crossing points. Now that might be difficult right here to tell exactly where, and we can trace and kind of get close. If you want to get the exact ones, what you want to do is in the y thing, we're going to make our second one 0. So we're going to graph a line right over that axis to help us out. And then what you do is you hit second trace. And we want to trace an intersection. Our first one would be that curve. Our second one would be our line curve. We'd hit enter. And we can see that one x-intercept is at negative 2/3 or negative 0.6 repeating. So, whoops, that would be one answer that I would have. Now we're going to find that other answer. So we'd go back here, and I'd go trace, and I'm going to move my trace over so that we can get closer to it, and we'll hit second calculate, and we'll do intersect from here to here, and we would find that that happens at 6, and that would be my other answer. So again, all you have to do for this is you just hit y equals, put in your graph, make your second one 0 so you have a way to intersect it, graph the two lines, and then anytime you want to do an intersection, do second calculate, and then just click intersect. And it will tell you every single time. Okay? Let's do one last type of problem. Let's do this last one. So for this last one, what they want me to do is they want me to create an equation given 3 points. And this one's a little bit trickier if we don't remember how to do stuff with matrices. So for this example, what you want to do is we're going to use standard form for it. And we know the standard form equation is y equals a squared plus bx plus c. And so we're going to use these points to help us out. We're going to make 3 new equations based on these points right here. So the first one would be negative 2, instead of putting y, I'll put negative 2, equals a 1 squared plus b 1 plus c. My second equation, let's use a different color, would be negative 4 equals a 2 squared plus b 2 plus c. And my third equation would be negative 4 equals a 3 squared plus b 3 plus c. Now, what this should look like is it should look like a 3 by 3 matrix that we could write. So the 3 by 3 matrix that we could write off of this would be 1, 1, 1, 4, 2, 1, and I put 4 because 2 squared is 4, and then 9, 3, and 1, with my matrix being A, B, C. And that would equal our answers, which our answers in this case would be negative 2, negative 4, and negative 4. And that would be my matrix. Now we just think about how we would solve this. We take the inverse of both sides. That would cancel that out. And then A inverse times that would be my answer. So let's put that into our calculator. So when we put that into our calculator, we'll go to second matrix. We'll edit that first matrix. Put in a 3 by 3. Whoops. 1, 1, 1, 4, 2, 1, 9, 3, 1. We'll hit second quit. Go to second matrix again. We'll go to edit. This is a 3 by 1. We'll go, whoops. We'll go negative 2, negative 4, negative 4. Second quit. And we'll do matrix A inverse times matrix B. And this would be A, B, and C, and we would have our answer is to plug in with 1x squared minus 5x plus 2. If you have any questions, please ask.